In this video, I'll talk about the eigenvector and the eigenvalues. Well, these are uh, eigenvector and eigenvalues. Okay. Uh, so, if you are comfortable with vector algebra, so let me give an introduction to vector algebra. Okay. So, this is x, y, and z. So a vector v can be represented as a1, a1 x1 plus a2 x2 plus a2 x3, something like that. Okay, and if you want to really increase, if you want to extend this to further, you need to multiply this with a constant, right? So let the constant be lambda plus x3. Okay. So this lambda is a constant which transform this vector v and it increases its length. Okay, so that's one type of transformations. Sometimes you can also change the direction of the vector v by multiplying it with a constant. Say for example, if you multiply -1 to this, okay, so it's going to be -1 and then a1 x1 a2 x2 plus a3 x3. Okay, so when you do that, it actually goes to the negative side, right? It changes its direction. It's diagonally becomes opposite in opposite directions. So the idea here is that by multiplying with a constant, you can change the direction as well as the magnitude of a vector. Okay, so how is it related to the eigenvalues and the eigenvector? Okay, well, so in this case, so what we're trying to we're trying here is that uh, lambda, like any constant which changes that values, we call that as eigen eigenvalue. Okay, we call that value as eigen. So every matrix can be represented with some sort of uh, this form. Okay, so this particular matrix A is is a product of lambda to a dash, so some other matrix. Okay, so lambda in this case is known as the eigenvector and a dash is the lambda is the eigenvalue and a dash is the eigenvector. Okay, so and why is so? Because every vector is some form of transformation of some other vector. Okay, so we simply say that, okay, we multiply a constant one vector and we get another vector. It's like saying, every every number on the number line is a product of two numbers all the time. Say for example, 23 is a product of 23 into 1. 22, it's a product of 2 into 11, right? Similarly, every matrix is a product of a eigenvalue and an eigenvector. So how is it related to our analysis, and why should one study this? Okay, now let me tell you how you can actually find this one. Okay, so if you want to find out eigenvector or an eigenvalues of matrix A, so you need to use this equation. Okay, lambda I, and determinant of that should be 0. So determinant of matrix A minus lambda multiplied to the identity matrix. So identity matrix is nothing but matrix like this, should be 0. Okay, so you can actually find eigenvector and eigenvalue of this by this one. Okay, when you solve this equation, you will be able to find out the value of lambda. Okay, So that's how you find out the eigenvector and eigenvalue. And why is it so important? Well, in the cases of the principal component analysis and the factor analysis, knowing this sort of transformation is very important. Okay, because your data points will have, x1, x2, x3, x4, and you have bunch of data, right? So you actually transform this data into different, you transform into data and you try to find out the eigenvalues, different eigenvalues. So you can have multiple eigenvalues as well. So eigenvalues of that. So eigenvalues will capture, will tell that what are the most important transformation which we should capture, so that this transformation will be retained and the not so important transformed matrices will be retained. Okay. So that's why in the data reduction or data reduction techniques like PCA and factor analysis, this is important. You do matrix decomposition. Okay, matrix decomposition, where you create from the large matrix where you have number of variables. You create a small matrix by doing some sort of a transformations. Okay, so that's exactly where the eigenvalues and the eigenvectors are important.